Thank you. I'm a futurologist. What I do is I look at the future and study it all the time. What I do is I try to figure out, by meeting lots of people like Steve, how smart they are. And how smart really is Steve? What do I think he's going to be able to achieve in the next 5 years, 10 years, 15 years, and his successors who he's now training up? All I need to know is how smart other people are. I don't need to be smart myself. And that's my really good get-out clause. So I'm going to talk about the future based on what Steve and his successors will be able to do over the next 20, 30 years. He's just hinted that there's a circular process here, that the smarter the brain science gets, the more insights we get into neuroscience, the better that feeds into AI. Then we can design gadgets even better to go into the brain to get more insights from the brain to figure out how to make better AI. And it's a nice circular process. And as we go around this, it accelerates. When you start deviating from Moore's law, it actually accelerates upwards. It's a positive feedback cycle. And it's always been like that, but the deviation's been quite small so far. In the future, the deviation will get quite a lot from a straight line. Even on log paper, you will see a very exponential curve from Moore's law. So where do we go from that? Well, what we're heading towards is a world of future life on Earth where you've got human Mark 1. We're going to be still here, still doing the same sort of thing for quite a while. But already we're starting to develop cyberspace life, and going right back to Rod Brooks and various other people in the early 1990s playing with things like the Sea Zoo, and they've now got robots wandering around the living rooms doing vacuuming and stuff. In the long term, these robots will pick up on the neural architectures in our brain, they'll learn from their environment in the same way as you do, and they will get really, really smart very, very quickly. So cyberspace life, it's only a matter of time before you start classifying that as life. Today, there's no way you're going to classify as a computer virus or a worm or something as artificial life, nor should you. Give it another 10 years. I think you'd be debating that a bit more seriously. But there's a blurred boundary already because we're starting to make links between the chip world and the human world. A lot of people have got cochlear implants. Some people have got the top of their head opened up and chips directly stuck into their cortex so they can control their wheelchairs. Today, you only do that with severely disabled people. In the future, it's going to be cosmetic surgery. A lot of people will be doing that. So I would suggest there's actually a three-way, it's a triangular thing, natural world, Mark 1 humans, cyberspace life with lots of conscious machines, not very far away, probably 10 to 15 years at the very most before we get these conscious machines, maybe even less than that. And then we've got the whole capability of modifying nature, of making nanotech, biotech, infotech, and cognition. All that convergence is coming together. $10 billion a year of research says this isn't a mistake. We got the real world being modified in terms of the organic environment to make it a blurred boundary between what you can do in a computer and what you can start doing inside a machine. And I'm looking forward to getting a hamster and sticking a chip in it, which is 1 millimeter squared, and giving it a higher IQ than the guy who just trashed RBS, so we can get some of the taxpayers' money back. Now, where does this go? Well, what we're at today, very firmly, is, these sort of robots, state-of-the-art Honda or Sony or something. We got those sorts of things coming out of the production line. Lots of vacuum cleaners and robotic hedge trimmers and things like that. Gradually, we're heading towards the iRobot sort of stuff that will do all your housework. Some of the Japanese companies reckon you might be able to buy one of these for a few £1,000s by about 2015 to 2020. And who am I to argue? I think that's quite realistic. In the very far future, they're part of your family. Even more than your pet cat or your pet dog. Some of your best friends by 2020 will be computers. And that doesn't require you to be an IT person. Anybody will have some of their best friends as computers. The reason is that today, you are the really big bit, and they got a tiny little bit of computing underneath you. And as we just heard from the previous talk, computers are quite smart, but compared to what's inside your brain, they're really peanuts already. But they're continuing to improve by Moore's law, and you aren't. So you'll still be the same in 10, 15, 20 years' time, minus 1 neuron per second or minute or whatever it was. But the computer is going with Moore's law. Eventually, it'll occupy 99% of what you do, and the other 1% of your brain is just occupied with telling the computer what it is you really wanted to do. That's where it's really going. I think we're heading towards conscious machines with a high degree of rapidness now. And, I've stuck in a few things in here like Heisenberg resonators. Chips work because they get around the analog computing decays and changes of the performance of the transistors and things. Chips work because they clock it. Every now and again, you do a sampling of what the signal is, and you lock that down, and you start it from scratch again for the next cycle. That's why a digital chip is better than an analog computer. You can do the same thing, I believe, with quantum computing. I just wish I could remember enough quantum mechanics to make this actually work in real life, and I'd be a rich guy. But a Heisenberg resonator does that. It clocks the computing world so that we can tap into quantum computing. It taps the analog world so we can use the analog side of how neurons work inside your brain. And using all these figures of 10 to the 15 neurons, but your neurons only work at 200 meters per second at a maximum of about 200 hertz, your brain is pretty pathetic compared to something you could buy in PC World this afternoon in terms of the speeds. So if we can get the techniques right and get the miniaturization a bit better, we can really do something with this kind of stuff. And we looked already, a lot of people around the world are looking at internal sensing and sensory vortexes and how does consciousness work. A lot of this work is already going on. I promise you, within 10, 15 years, you will have computers which are much smarter than you, with better emotional capability, better sensory capability, much better IQ, better storage, better everything else. And the only thing you'll be worried about is how the hell do I connect to this computer? And you will have to do that connection. Otherwise, the computer will say, you're now my employee, and I want you to do this, this, and this. Now, we don't want that kind of a world. Now, where does this start? It starts with custom DNA, because DNA has already been shown to be the way that you now assemble electronics from the ground up. Moore's law is fizzling out in terms of the old ways of doing things by blasting X-ray lasers and things at a piece of silicon and blasting away channels and then doing some acidic erosion and stuff. Those techniques are wearing out. We're running up against the limits as far as that goes. We're going to have to start assembling molecular transistors from scratch. We don't have a molecular transistor yet, but somebody out there in some university is working on it right now, and they will achieve it in due course. And then I can pick those things up with a piece of DNA using this particular shape of molecule and latch onto that and stick it to this piece of molecule, and eventually I get a circuit. Now, the demonstration of this is almost 3 years ago. You can do this. Those companies are now working on the more sophisticated circuits. They will get to the point where you can use proteins from ordinary DNA and ordinary molecules inside ordinary cells to assemble electronics. And then what they want to do is dissolve away the bacteria and leave the electronics. I said, well, sod that. The bacteria is actually quite a good power supply as well. It's got mitochondria. It can use ATP and provide you with electrical power for the chip. Let's leave the chip in situ inside the bacterium, and let's make a smart bacterium. Let's make the smart bacterium and give it some of the bioluminescence to communicate to the bacteria next door. And let's, in short, let's make a pot of yogurt with so many transistors and things inside there, and such a good architecture that a pot of yogurt, regular size yogurt from Tesco's, is roughly the same IQ as Europe. Now, you might consider that as a productivity tool. I would say it's called SIR. Now, how do we get around that SIR problem? How do we make this our slave? God knows. Let's figure it out. But along the way, it's going to be really quite interesting, because as AI progresses, you think about playing some of the games you play. I mean, The Sims is, I think, is the best-selling game of all time, still, I think. And my daughter plays with The Sims a couple of hours a day when she's not on Xbox, killing little old ladies on Grand Theft Auto 4. She plays with The Sims. What does she do on there? Well, she's playing with little communities, and she's telling them what to do. But supposing The Sims are smart, supposing that so much AI that they're smarter than she is, she's controlling a community of conscious entities which are smarter than she is. Is that fair? Should we allow that? What is the ethics of it? Well, God knows. You should be thinking about this. It's not my problem. I'm 48, going on 49. You're the students. It's your problem. You've got to solve that. Me and Steve did the chip design. It's your problem to solve these really big ethical problems of the next generation. I don't care. I'm retiring. Should we allow sentient beings to be controlled by kids, less than 10, 15 years old? They haven't got enough wherewithal to know how to do this properly. How long is it going to be before you stick all of this into a robot and stick that on Robot Wars so the robot cares whether it gets killed or not? And if we get to that point, and you've got some synthetic blood and guts and stuff as well, you will watch that, and the viewing figures on Sky will go through the roof, the more gory that is. Are we in danger of going right back to the, the bare bones of human existence that we always looked down on from the Roman era, of watching Christians fighting lions and getting heads chopped off in Roman Colosseum? There is a very, very thin veneer of civilization between you and them. Very, very thin veneer indeed. Now then, pandas. I love pandas. Pandas are really cute and cuddly. I'm sure they're not when you get right close and they stick your claws into you, but pandas look really cute and cuddly. Pandas have got a lousy sex life, and I say that as an IT engineer. Pandas do not know how to bonk. Pandas don't know how to find a girl on a Friday night. They don't know any of the basic rules. Let's redesign pandas. We can do that in the next 20 years. I do not want pandas to go extinct. I will put whatever money into World Wildlife Fund for Nature as required to stop pandas going extinct. Let's get there. Let's give them a GPS chip in their brain directly linked to their cortex. Let's give them a better libido so they actually want to bonk the panda once they meet them rather than talking about history or something. Let's make pandas bonk more and make more baby pandas. Let's do that. Let's redesign nature. And as we go through that process, let's look at the whole AI thing and linking things directly from inside their brain using chips to the network and the vastly enormous power that we can produce on the network compared to what you can do inside your brain. Let's give the panda, human level IQ or 100 times human level IQ. What happens once you start experimenting with this? Before you can put chips inside a human brain to connect you to a machine, someone wants to demonstrate that this is safe by doing it to a hamster. And when you get the first hamster with an IQ 10 times as high as the highest IQ human being, Einstein or somebody, what do you do with that hamster? Can you just put it to death when it's 10 times smarter than you are, 20 times smarter? This is a really big ethical problem. You have to experiment on animals before you do it to people. At some point, you will have a superhuman hamster. Now, I don't care how stupid that sounds, but you will have to go through that stage. And chimpanzees and even smart bacteria. Now, e-babies is recognizing that you've got this link to the human world, and you can do this all with people as well. One of the people I used to be a boyfriend of, she is sterile. She would love to have kids, but she can't have kids. And she would dearly love to have kids. And I says, well, you can't have kids, so what? Well, so what is in 20 years' time, we'll have the genetic capability so you can walk into a clinic and get a piece of your DNA mapped, and you can get your entire genome. And you can decide which person out there, boy or girl, doesn't matter, and you can say, who do I fancy, who do I want to have a kid with, get their genome, walk back home to your PC, put both genomes into your PC, randomize the connections, and make a virtual human being. And you can do this billions of times with billions of different people. And then you can sell them on eBay. Because each one of those combinations, if you're a celebrity and she's a celebrity, each of those combinations is saleable, and you can make a lot of money from that. So where do we go from there? E-babies, that's where we go. And eventually you get the computer simulation where we know what this person's going to look like. We can probably even simulate what their brain's going to be like in a particular environment. So you can end up with virtual children. And then, of course, you can get the genes off the shelf from test tubes and assemble them, stick them into some human host, and 9 months later you get a real human baby. It doesn't matter if she's sterile. By 2030, she can have a kid, even when she's 90. And I've actually got a date with one of the directors from BT, I'm ashamed to say, but I've got a date. When she's 94, we are going to make an e-baby. I'll be 102 or something at the time, but never mind. We're going to leave you with this, is we see a future for humanity where gradually you're getting smarter, you'll be able to modify your genome, make Homo Optimus, whatever. Then the link to the computer is getting better, Homo Cyberneticus. Let's optimize your gene and give you the computer link. Let's make Homo hybridus. And then by then you're merging with computers which are also migrating into Machinus sapiens, or whatever you want to call that, Sim sapiens, Bacteria sapiens. All of these things will start converging, and you can start making intuitive links between them all. And we end up with not just Homo Machinus, but Homo sapiens. And then you start linking into the rest of the organic community, and we get Gaia sapiens. And I don't believe in Gaia, I think it's a load of crap, but you could make a Gaia if you wanted to, and you could link everything electronically together into a future. So my final slide, I'm going to leave you with this thought. What does your post-organic life look like? When you die, your body dies, it decomposes in the grave. So what? Before you died, you've already got 99.9% of your brain is working inside the internet. We've got so many chips inside your brain, taking all your thought patterns and replicating those in a replica of you inside the computer world, Homo cyberneticus. So, John Smith Mark II, but instead of 200 meters per second, it's the speed of light, 200 million meters per second, and instead of 200 hertz, it's 200 terahertz chips and stuff. So you've got billions of times more capability, and your sensory apparatus extends the entire world. So you are part of the global consciousness of all things before you die. Looking around this room, almost everybody in this audience should be immortal, except me and Steve. And I'm really pissed off about that. But the fact is, you will probably live, if you want to, forever electronically. Because by the time your body dies, given that the biologists are getting better and medicine is getting better, you will have such an intuitive link to the computer networks that most of your mind will be running inside the computer network. And when your body dies, it isn't a major career problem that you're dead. You just pick up an Android from B&Q or Computer World or something, and you go back to work on Monday morning as if nothing had happened. That's the kind of future that's actually possible. I don't care about the credit crunch, that's just noise. The technology says you can do this, and you will do this. And the pension funds can go to hell, I don't care, because I'm going to be living in cyberspace. But really, I am so pissed off. I am the last generation of organic life that will die just before this happens. And almost all of you, as the audience, are going to live long enough that you will see this happen. I'm going to leave you with that thought. I am really pissed off. You've got it. I haven't. I am annoyed. So there we are.
Thank you very much. I'm sure there must be some questions. Anybody? Throw your hand up in the air.
Yeah, that was precisely 18 minutes, by the way.
Yes, thank you very much for a very insightful lecture. So I'm glad I'll live forever. But I believe there will be a consequence of all these. Nature has a role to play. We can't just do things the way we think it will work. We talked about, I'm from an oil-producing country, and we have talked about stopping the need of oil. And we started talking about producing energy from ethanol, and the impact has been shortage of food around the world. So anything we do has a consequence. You have talked about it from one direction, what we can probably achieve, but what do you think will be the consequences of all these actions we are going to take? Thank you.
Yeah, I think the oil-producing side of it is trashing nature. We're running with greenhouse gases and global warming. We're quite likely to wreck an awful lot of the environment. So starting from that point, we already have a solution for the energy problem, which gives us far more energy than we can handle, which is the Sahara Desert even produces 100 times more energy than we can use in Europe as a whole, and Texas and stuff produces all the energy for the US and Australia for the entire Asian bloc. We've got far more solar energy even than we can possibly use. That's a really good solution for that. In terms of nature, once we've trashed a third of the ecosystem, we can redesign it. We can do the Panda 2.0, Rainforest 2.0. Once we understand fully how the genome works, we can design the stuff from the ground up. That might be hubris, but I don't really think it is. I think we can actually do this in the 50-year time frame that these consequences are going to hit us from today's big mistakes. So providing we don't make too big a hash of it that we actually get wiped out in the meantime, technology catches up with the problem, basically, and we can solve it. The really big danger is that the problem gets ahead of the technology in the short term, and we get wiped out. And if that happens, well, nothing we can do about that. Let's just hope that us as engineers can accelerate the technology fast enough that we can get ahead of the politicians and decision makers and the problem that they're causing. But the energy problem, we can solve. The environmental problem, soluble. And these other things can be done. But we've got to work at it. It isn't going to happen by default. We've got to work really hard to make sure that acceleration curve continues. And Moore's law, as we heard, continues for another couple of decades. Next question.
Another question? Yeah.
Hey there. You said that to get conscious machines within 10, 15 years. whereas most other sources I've heard reckon it'll be around 30, 40 years before we see that kind of level of thing. So the first question is, do you know of any projects that are, like today, that are working towards that goal?
Well, mine is, and I'm looking at things like Heisenberg resonators, Pauli switches, and things like that, and taking all the insights from neuroscience, looking at how we can use this in things like smart yogurt. I think where the other scientists that are saying these 30, 40 years are going wrong is they're not aware of the whole field. Most scientists are very, very specialized in a particular niche. They don't see what's happening outside that. As a futurist, I'm looking right across the board, and I'm seeing the guys in University of Oslo doing this stuff, and University of Cambridge doing this, and Harvard are doing this. And I'm linking it together, saying, well, eventually these guys are going to publish their results, and they're going to talk to each other, and they will get there. And I've been really fascinated the last 15 years. Kurzweil and I came up with the same idea about 1990 of conscious machines, exactly the same technique. And he then said, artificial life, human consciousness level, 2050, 2045. Since then, he's brought his things forwards by about 5% every year. And he's now not very far away from the same estimate as me, because he's now discovered this positive feedback cycle, where the more insight you get into brain science, the better your AI gets. I will still stick with my date of 2015 to 2020, and all the other scientists are gradually coming forwards towards that date. I'm not going to adjust mine.
Second question. You seem to suggest that engineers will sort of release this technology just on the world and then deal with the issues afterwards. Like I studied computer science because I wanted to make technology that help people. But don't you think it'd be wiser to consider the effects of the technology before it's developed? And sort of, we still live in a world with war, dictatorships. Would it be wise to release like intelligent robots in such a social environment?
Yeah, it'd be very wise, but people, once they're faced with a patent and getting rich quick, don't always do the stuff which is wise. You asked the Royal Bank of Scotland about that right now. People knew this was going to go tits up. I was reading articles in Time and Fortune magazine about how this financial system was all going to go tits up anytime soon. Everybody knew that was happening. The guys who were saying, well, this is all a surprise and we didn't expect to go broke, they're lying. They knew this was going to happen. They knew they had a short-term bonus reward scheme, which they'd be out of the job by the time this was going to go wrong. People knew this financial crisis was coming. The same goes to the engineering. If you can get rich quick, and you will do that by getting this engineering thing out on the road, you will still do that, even if you know your successor has to pick up the rap and your kids have to pick up the, the finance for the next 30 years. That's human nature. Human nature always trumps wisdom. Always does. Sorry.
Okay, we have time for one more. Yep.
I was told I'm going to get 2 questions. I'm being short-changed here.
This may sound like I'm trying to draw a kind of feeble analogy, but so way back when people were first riding horses and then inventing trains and so on and so forth, they thought, well, okay, we can just get faster and faster and faster, travel can go whatever. And then Einstein comes along and says, well, actually, you've got a limit on the speed that you can travel. So and that's not a limit on technology or anything like that. That's just a physical law of nature. What sort of physical constraints that are purely based on the laws of nature do you expect to run up against when you're...
I'm glad you asked that. We have done this calculation. You can get an entire contents of your brain in terms of performance and memory and sensory capability in 1/10,000th of a pinhead. And it will take a few milliwatts to power that. Now, given the amount of solar power available, that means you can support a virtually infinite human population inside the computer. That may be your career path, a few hundred years of being alive, plus robot, plus everything else. And then you decide just to live in cyberspace the rest of eternity or something. Maybe that's your career path, but it's, there aren't really any big limits on this. We're not actually constrained to Earth. Before that runs out, you'd be looking at other planets and asteroid mining and everything else by 2050 onwards. So I don't really see any big limits. There's an awful lot of space out there, an awful lot of energy out there. The sun produces 10 to the 24 watts of energy, but there's an awful lot of suns, so there aren't really any problems within your lifetime that you need to worry about. Moore's law can carry on for several more generations, but engineers can never see any further than the next one because they're always worried about the problems they've got right now, and I can't solve this, therefore it can't be solved. That's the biggest mistake a scientist can ever do. You're smarter than me. I can't solve it, but you will. That's what I would give you as optimism. So as a futurist, I'm looking from outside this. I know, this guy's smart. He's going to retire quite soon because he's even older than I am. He'll retire, but you're going to replace him. And you're even smarter than he is. So I've got confidence as an engineer looking outside the system on a whole black box system analysis. I can't see it stopping for several more generations. And people have said Moore's Law is going to stop by 2015. I'm basically talking bollocks.